Okay, so we're continuing on with functions. We're going to look at some key terms here and some key terminology, things that are important for us to understand when working with functions here. So we've met that idea of an input. An input is a value that is put in, okay, for want of a better phrase, it's put into the function, and we usually use the letter x for inputs. For outputs, we can use f of x, which, as I said, is we think of that value of x being put into the function, so between the two brackets. Essentially, I just always think of it like the f with the brackets represents the function part, and whatever is inside there in the brackets is the input that has gone into the function. So we use f of x or we use y. Those are interchangeable. Using f of x obviously relates the output to the input that it came from, whereas y, I suppose, is cleaner when we're looking at maybe putting those inputs and outputs together when we come to graphing, and we come to things like that later. So it's important to have that idea of both. A couple then is when we take the inputs and the outputs and write them as an ordered pair or a couple. That's an xy, very, very similar to our coordinates that we've met before. Okay, essentially kind of fulfilling the same role there as our kind of coordinates. So taking an input and its corresponding output and writing them as an ordered pair in a set of brackets there. What we're going to look at is we're going to look at a few key terms that are all to do with the inputs, the outputs, okay, and the kind of subcategories underneath that. The first one of those is the domain. The domain is the set of inputs, and I'm going to write in brackets here, that's my x values. So the domain is the set of all x values. This will usually be given to you in a question. They will identify the domain. They could do that in a number of different ways because functions are usually so expansive in the sense that, like, you could nearly put any x value into it. A lot of the time, this might be identified using an inequality. So we might say, for example, we might see something like this, which means x is between 0 and 7. Or we might see something that is just x is greater than or equal to 2. We could see anything like this. And this just tells us that the values we're going to input, okay, it gives us some sense of the inputs that we're going to be using. So obviously seeing something like this top version sets kind of a limit on us. It gives us a lower bound and an upper bound. It means that we're not obviously going on forever. We're filling in certain values, specific values into our function and inputting them. Okay, so the domain is fairly straightforward. It's the things that are going in. The range and the codomain are very, very closely related. Okay, I'm going to start with the range first of all. So in theory, the word range means kind of how far do we reach nearly. You know, if someone has range, they've got a wide skill set, I guess. So range here in terms of my functions is the set of actual outputs. It's the outputs that I reach. So what is within the range of my function? What is my function going to be able to reach here? And obviously that's dependent on the inputs that I put in. So the range is, as a result of these inputs, what are my outputs? So it's the set of outputs that I get. The codomain then is the set of possible outputs. Okay, the things that could have been my answers or where I find my answers. So what that might look like is, let's say, for example, the codomain could be the set of natural numbers. So actually y. So let's say the codomain is the natural numbers. The actual outputs might just be 2, 4, 7, and 8. Okay, so the codomain is the set of possible outputs. So there is potential for me to have any natural number based off this function, but obviously that depends on what I put into the function. And then once I know what I've put in, I will be able to work out exactly what the outputs are, and that's the range of the function. Okay, there's a nice little example here, which I think can kind of lay it out quite clearly. So we're looking at essentially a coffee menu or a cafe menu, and we have our customers, and then we have the menu on the cafe, and we have also the orders that these customers have placed in the cafe. So in this scenario, the domain is the customers, the people who've gone in, they are the inputs into this scenario. The range then would be the drinks that they have ordered. The codomain is the entire menu. So they could have ordered anything from the menu, but they have ordered specific things off the menu, which kind of fill out the range there. Okay, so the codomain is the full menu, but the range is the specific drinks that were ordered by our customers in the domain. So it's just important to have that concept, and really it comes down to the distinction between the codomain and the range. So think of that idea, it's the range of our function. What can our function reach to? What can it get to? What is within range for our function, depending on those inputs, depending on what we put into it. Okay, so let's get into some of the examples here, I suppose, on that. The following diagram, and this is a mapping diagram, okay, we saw one of these in the last one as well, so it shows us how inputs and outputs are mapped to each other, how they're connected by those arrows. It just means this input, once it goes through the function, this is the output that comes out of that, and here's how they're all linked. So this diagram represents a function x squared plus 1. We can see there straight away -1 and +1 are both mapping to, or they both have 2 as their output, which makes sense because there's a squared in there. So both the negative and positive version of 1 actually end up giving us the same output, which is fine. It still qualifies as a function. We're asked to list the elements of the domain, codomain, and range. So let's start with the domain. The domain is where I start my function. It's where my inputs are. So I'm looking just for my set of inputs. So that is all of my inputs here. The codomain, which is often maybe the next one that I would look at, the codomain is the set of all possible outputs. In terms of my mapping diagram here, that is all the numbers that I could have mapped to, that could have been possible answers. So in this case, that's the 2, 5, 10, and 12. So we can see there 12, none of my inputs actually go to 12 or end up giving me an answer of 12, but 12 is there as a possible output. Okay, so maybe if I'd gone further with my question here, 12 might have been a possible output that I could have reached. The last one then is the range, and the range is the set of outputs. It is the outputs that I actually get to. In a mapping diagram, it's the ones that the arrows point to, so 2, 5, and 10. In terms of listing the couples from the function, that's a matter of taking each input and matching it up with its corresponding output. So -1 and 2, +1 and 2, 2 and 5, and 3 and 10. And those are all my couples for my function here. Okay, let's go into another example or two here into these exam questions. So we'll use them as nice examples. We have another mapping diagram here. The first part asks us to fill in the missing entries. So that's going to first of all require us to look at what the function is. In this case, the function here is given at the top. It's using one of our different function notations, but essentially what it's saying here is that every input, and then the arrow, which we said represents maps, every input goes to that input squared. And we can see that in the first example. 5, once it goes through my function, becomes 25. So remember, the arrows here are kind of representing that box, that machine idea we had before, where the function is just, it's squared. So whatever goes in gets squared, and we get an answer. So if 3 goes into the function, if it gets squared, okay, so it's 3 squared, so we get 9. -6 goes into the function, so that's a -6 squared. Anything squared will be a positive answer, so 36. 0 squared is still just 0. And on this one, we have a slightly different way. We need to go the opposite direction. Something squared is 49, so the something is probably +7 then. Okay, so the something is going to be +7. Okay, could actually be a -7 as well, but let's use +7 as our answer here. So write down the range of the function. Now the range is the set of outputs, the actual outputs. Okay, what does my function actually reach? So we're going to include 0, we're going to include 9, we're going to include 25, 36, and 49. So in this case, all we really had to realize was that the answers were the right hand side here. We're within those outputs, because every output is actually there. And in this one, that's an interesting situation, because if we were asked for the codomain is this entire circle as well, which is actually the same. So this function, the range and the codomain are actually the same. Looking at another example here, we're asked to write out the domain and the range of this function. It's written out as our kind of couples here. So let's look at that. The domain, as we've said already, is the inputs. That would be the x values. So we're looking at like 1, 2, 3, and 5. And the range then is the set of outputs, that is the corresponding y values. So 5, 8, 9, and 10. I don't know what the function is here. They haven't given me that information. I could possibly work it out, but I'm not asked to. Looking now at the last example, we're given another function here, another relation, and we're asked to write out the domain and the range. So again, the domain is the inputs. That's 1, 2, 3, and 4. And the range is A, B, and C. Remember, for a set, we don't repeat any of our elements. So that essentially summarizes codomain, domain, and range. So domain is my set of inputs, codomain is my set of all possible outputs, and the range then is the set of actual outputs that I actually get to. Okay, very important to know all of those words when we're answering these questions.